In this question, four identical resistors are connected to a battery as shown. Each resistor has a value of 120 volts. Resistor R4 is removed. What is the effective resistance of the circuit? How it affects, okay? When you remove R4, how the effective resistance is affected. That is the question. Now, first of all, we have to calculate what will happen before removing. What is the effective resistance before removing R4? Then you calculate after removing R4, then you compare the value. Only then we know how much it has decreased after removing R4. Okay. First of all, before removing R4, what would be the formula? R1 is in series. Series with what? Series with the three resistors which are in parallel. So it will be like 1 over R2 plus 1 over R3 plus 1 over R4. Now after removing, the same formula changes to R1 plus 1 over R2 plus 1 over R3 alone. R4 is removed. Okay, now substitute all the values. 120. R1 is 120. Okay, then 1 over 120 plus 1 over 120 plus 1 over 120. Be careful, this is 1 by R. This parallel resistance, you remember the formula for parallel resistance? It is 1 by R is equal to 1 over R2 plus 1 over R3. So don't forget to invert this one. So I'm going to calculate first the one which is in the bracket. So that is going to give me 3 over 120 or 1 over 40. So this is 1 over R. So what is R? R will give me 40 ohms. Now add this 40 ohms with the 120, which will give you 160 ohms. Okay. Now repeat that for after removing. So after removing is going to be R1. Again, I'm calculating only the one within the bracket. R1 by R2 is 1 over 120 plus 1 over 120, which will give 2 over 120 or 1 over 60. This is 1 over R. So R will be 60 ohms. You do this only for parallel resistance. Okay. Then, so R1 is 120 ohms plus 60 ohms, which will give us 180 ohms. Look at the difference. Before it was 160 ohms, now it is 180 ohms. So the resistance has increased by 20 ohms. So the effective resistance increases by 20 ohms. So option C is the right answer. Okay. Thank you.